right here, I just want to remind you to once again look at the exponential growth and decay functions at the bottom of page 5. Those are going to be really, really helpful. So the exponential growth and decay functions are going to be a times 1 minus r to the x power, and then you also have a times 1 plus r to the x power. And just remember that the one where you're adding is your growth, and the one where you're subtracting is your decay. Decay just means that something's decreasing. All right, so let's look at this example. It says Ryan bought a brand new car for $18,000. Its value depreciated. Depreciated means it's going down at a rate of 1.2%. And we're supposed to write a function to represent the value of the car as a function of time. Use technology to estimate the number of years it will take for the value to reach each given amount. So let's start by writing the function. We're going to use the decay model because it's decreasing. So to write that model, we're going to substitute in our starting amount for our A value. So our starting amount is 18,000. And then we need to subtract the rate. And don't forget, before you plug in the rate, you need to do the rate divided by 100. So 1.2%, you need to divide that by 100. So that's going to be 0.012. And this is your function. So that's your part A. And then it says to use technology to estimate the number of years it will take for the value to reach each given amount. So technology is just Desmos. In our case, that's the technology that we're using. So we can go ahead and graph this function or just plug the equation in and see what it looks like on Desmos, and then use that graph in order to help us answer these questions right here. Let me just make sure I wrote it down correctly. 0.012 x power. Yeah, so this is what it would look like. And if you notice, you cannot see your graph at all, and that's because we're starting at 18,000 and our graph, our y value is only going up to 7. So we need to change our y value to be 18,000. And then I'm going to go ahead and change my my x value because this is only going to 10 years. So it looks like it's going to take a little longer than 10 years. So we'll do like 25 years maybe. And you can start to see a little bit better the value of the car. So if you look right here, this is our starting value. This is our y-intercept. So on our graph here, we're starting at 18,000. And then if we were to just go out by, excuse me for all that. If we were to go by 5 years, so you can just copy and paste here. If we were to go out by 5 years, that's going to give you 16,945. That's going to be 5 years. It's going to be about right here. So that's 16,000. We need to determine when this value is going to be 17,000. So what you can do is set your y equal to 17,000, and you can find that exact amount right here. So in 4.735 years, our car is going to be worth $17,000. So it's going to be happening. This is approximately what our graph looks like on Desmos, but it's reaching that point a little bit before that 5-year mark. You're getting to 4.735 years. It's a much better to look on Desmos at the graph. So if you just set your Y value equal to 17,000, you can see that at 4.735 years, that's when it's going to reach that value. And then let's look at the next question. For C is 15,000. So we're going to set Y equal to 15,000. And we're just looking for where they intersect. So I could do Y equals 15,000. And I can see that my car's going to be worth, or the car's going to be worth $15,000 in just over 15 years. So 15.1 years. Half of the starting value, that is going to be whatever half of $18,000 is, which is 9,000. So I'm just going to set my Y value equal to 9,000. And I can see it's going to be worth half of the starting value in 57.4 years. A third of the starting value, that's going to be whatever a third of 18,000 is, which is 6,000. And we can figure out that is going to be, I'll just change this to 6. It's going to be worth a third of the value in 91 years. And you can do 0 and 10,000 by setting Y equal to 0 and set Y equal to 10,000. And you're just looking for where the graph would cross. So like 10,000 would be about right here. I'll let you go ahead and figure that out by plugging in the value. And then for 0, when is it going to be worth 0? Be careful because this is going to be your asymptote. So you need to kind of estimate when it gets to be so low in value that you would actually call it 0.